Hello, Langham Creek Algebra 1. This is Missy Wulo, and I will be working select questions from your fall semester final exam review. Everyone should have received a final review from your teacher. So let's get started with number 1. Sarah entered data into her calculator. We have a line of best fit and some data, and we need to figure out what we need to do to this line of best fit or trend line to fit the data a little better. So what I'm doing with this red line here, you can do with your pencil on the test. So here's our trend line, and then the black dots are our data. The first thing I notice is that while my trend line is here at a y-intercept of 0, my data is up here that has about a y-intercept of 4. So the first thing I need to do is take my line, my trend line, and move it up to the y-intercept of 4. So the first thing we did was move the y-intercept, or let me use math language, translate the y-intercept up 4 units. That was the first thing. The second thing I notice is that the line does not go through the middle of my data. It does not fit the data. So I need to adjust the line by making it a little flatter. Oh, let me fix that. I need to make the line a little flatter. And if it's about here, it goes through the middle of my data. So when we make a line flatter, so we made the line flatter, what that means is that we are decreasing the slope. Okay? So we needed to move the y-intercept up 4 units, and then we needed to decrease the slope to make the line flatter. So that is number 1. Number 2. Number 2, you're going to work the same way that you did number 1. You're just going to take your pencil and draw a line of best fit or a trend line like this. And what we use a trend line for is to predict. And it's asking us to predict how much money she would have made if the stand was open in 8 hours. So let me go to 8 hours, which is here, go up to my trend line, which is here, and she would have collected about $7. Okay, so that's how you'd work number 2. Number 4, let us describe the slope of this line. So we learned a little bit ago about slope man or slope face or whatever you called that, slope woman. And we had an eyebrow that's going uphill with a positive slope. A line that's going downhill has a negative slope. A vertical line has a slope that's undefined, and a horizontal line has a slope of 0. Now if I look at my graph, if I'm driving a car on this line, that car would be going downhill. So we are looking at this eyebrow, and that tells us that a downhill line has a negative slope. So how I can describe my slope is that the slope here is negative because the line goes downhill. The next one is number 6. The ratio of delta y over delta x is also called. Okay, well let's look at where delta y over delta x comes from, and then we'll talk about the other name for it. So if I have a table, and let's say my x values are 1, 2, 3, 4, and my y values are 2, 4, 6, 8, well, I need to find the change in my x values. In my y values. And what we call the change in x values is delta y. That means the change in my y values. So the change in my y values from 2 to 4 is adding 2, from 4 to 6, adding 2, from 6 to 8, adding 2. So I know that my delta y is a positive 2. Now let's look at the change in our x values, or in other words, delta x. From 1 to 2 is plus 1, from 2 to 3 is plus 1, from 3 to 4 is plus 1. So my delta x is 1. And 2 divided by 1, if I divide delta y divided by delta x, 2 divided by 1 is 2. And another word for this is slope. Delta y over delta x is how we find slope from a table. Other words for slope are also coefficient, which in y equals mx plus b is the m, or the letter in front, or the number in front of x. We can also see it as rate of change. And also from a graph, we call it rise over run. Okay, let me put this right here. Y equals mx plus b. The coefficient m, that's the number in front of x. Okay, so these are also other names for slope. The next one we will be doing is number 9. The first thing I would like to do is rewrite my equation because they're giving us C and P, which stands for the total cost and the weight of the package in pounds, but I'm going to change that to X and Y so I can put it in my calculator if I need to. So we have Y equals 0.50 X plus 250, where Y is my total cost and X is the weight of each package in pounds. Okay, so I just replace C for cost with Y and P for pounds with X. Now we need to find the range. And some of you may not remember what range is. Well, let me remind you. So what I asked my students to do is to make a little chart like this, X and Y. And what we say to ourselves is we go to the doctor. How do you abbreviate doctor? DR. So that stands for domain and range. I go to the doctor. I need my ID, independent, dependent, and I'm in and out. Input, output. And then to this table, we add first, the first thing that happens in a situation, and then Y is the second thing that happens in a situation. So if I'm looking for range, that means I must be looking at my Y values. Because here, R stands for range, and range is my Y values. So let me make another chart, X and Y. I'm missing my range or my Y values, and they gave me my X values, which are 1, 2.2, and 1.8. So let's find our missing Y values. Okay, so my equation is here. Let me plug in my first X value. Y equals 0.50 times, my first X value is 1, so instead of putting X right here, I'm going to put 1 plus 250. Okay? That gives me a Y value of 3 when I plug this into my calculator. So the first value in my range is 3. Now let's plug in the second Y value. Y equals 0.50 times 2.2 plus 250. Okay, that's going to give me a Y value of 3.6. So the second value in my range is 3.6. Let me plug in my third value. Y equals 0.50 times 1.8 plus 250. When I plug that into my calculator, I'm going to get a Y value of 3.4. So then the third value in my range is 3.4. So the way I'd write my final answer is the values in my range, and then I'm just going to list my y values, 3, 3.6, and 3.4. The next question that we are going to work out is number 11. Write the equation for the data in the table, okay? So we know that to find our slope from a table, we use delta y and divide it by delta x. So let's go ahead and do that. The change from my first y value to my second y value would be adding 7. And to type that in your calculator, you do bottom number minus top number. So to find the delta y, I do 1 minus a negative 6. Two negatives together like that cancel to make a positive, and 1 plus 6 gives me 7, so positive 7. Now from a 1 to 8, I do bottom number minus top number. 8 minus 1 equals 7, so the change is plus 7. From 8 to 15, bottom number minus top number. 15 minus 8, which is 7. So the change here is plus 7. Now let's find our delta x's. From 0 to 1 is plus 1. From 1 to 2 is plus 1. From 2 to 3 is plus 1. Okay, so my delta y is 7. And I need to divide that by my delta x, which is 1. And 7 divided by 1 is 7. So I know that my slope is 7. So in my equation, y equals mx plus b. I know that my m, or my slope, is going to be 7. So y equals 7x. Now let's find out what the b is. If we look in our table, I see something special. I have an x value of 0. And what that means is that when I have an x value of 0, whatever the y value is going to be my y-intercept, or my b value. So minus 6, there's my y-intercept. So there's your equation. Give another ordered pair that would fit the rule in the table above. Well, you can just type this equation into your calculator and look at the table. So let's look at that. 7x minus 6, y equals 7x minus 6. Go to your table, and you can write down any of these ordered pairs. So 636 or 743 or 850. I'll use 850. Okay? And you could have chosen any of those ordered pairs. The next one we're going to do is number 13. We need to figure out if this situation is linear. And the best way we can do that is by looking at a table for the situation. So let's make a table, x and y. So let's say that we're talking about hours here. So in the first hour, maybe he had 2 bacteria. If it's doubling every hour, then in the second hour, he's going to have 4 bacteria. And in the third hour, he's going to have double 4, which is 8 bacteria. In the fourth hour, he's going to have double 8, which is 16 bacteria. Okay? And the way that we can tell if this situation is linear, or if on a graph the situation is going to be a straight line, hence linear, we need to look at our change in the y values. Let's look at our delta y. So from 2 to 4 is 2. From 4 to 8 is 4. And from 8 to 16 is 8. Now let's look at the change in our x values. From 1 to 2 is 1. From 2 to 3 is 1. And from 3 to 4 is adding 1. So let's divide each pair of delta y and delta x. So my first delta y is 2. So 2 divided by my first delta x, 1. is 2. And let's look at our second pair. My second delta y is 4, divided by my second delta x, which is 1. And 4 divided by 1 is 4. My third pair, my third delta y is 8. So 8 divided by my third delta x is 1, is 8. And because, let me write this here, delta y divided by delta x. That's what we did here. And if I look at all these numbers, I got a different number each time. And another word for delta y over delta x is slope. So how can I have a line with several different slopes? Well, I can't. So because all of these numbers are different, we know that this situation is not linear, right? Because all of our delta y divided by delta x's are different, they're not constant, so this situation is not linear. The next one we're going to look at is number 16. And actually, you're going to work number 16 the way that we worked number 1 and number 2. So I'll leave that one to you. And let's look at number 20. Right? We need to write the equation for this graph. Right? When we talk about slope from a table, we talk about delta y over delta x. But when we talk about slope from a graph, we talk about rise over run, where rise is either up or down. If it's up, it's positive. If it's down, it's negative. And run is always to the right, which is always, always positive. Okay? And to write the equation for a graph, we need to put it in the form y equals mx plus b, where m is your slope and b is your y-intercept. So let's start by finding the slope. We need to choose 2 good points. A good point is my y-intercept, which is 4. And another good point is this one here, which is my x-intercept. Okay, so I'm going down by 1, 2, 3, 4. So my rise is -4. And I'm going right by 1, 2, 3, 4, 5. So that's a 5. So in my equation, my slope is going to be -4 over 5. And that goes with x. Now, my y-intercept is the point on the line that hits the y-axis. And that point is right here at +4. So in my equation, my b, which is my y-intercept, is going to be +4. So there's your equation for the line. Number 21. Oops. Number 21. Which following equation represents a vertical line? So we talked about a little saying called hoy. And then the second part of that saying was vux. And what that stands for is, for hoy, the H stands for horizontal line. The O stands for zero slope, because an O looks like a 0. So a horizontal line has a 0 slope. And the equation for a horizontal line is going to be y equals the y-intercept. Now for the vux part, we have a vertical line, and the U stands for an undefined slope. And then the x stands for the equation of a vertical line is x equals the x-intercept. Okay? And since we're talking about a vertical line, we know we're looking at the vux part. And the equation is x equals the x-intercept. So the answer is going to be x equals 8b. If we look on a graph of this, what that would look like is an x-intercept of 8. So this is my y-axis, this is my x-axis. So x-intercept of 8 would be 1, 2, 3, 4, 5, 6, 7, 8 would be here, and then the vertical line would go through that x-intercept of 8. So it would look like that. And there's another question on your review that is the same kind of question, but it asks what's the equation of a horizontal line. That's when you would use the HOI part, and you would work it the same way that we did this one. So the next question we're talking about is number 26. Okay, which of the following will produce a graph that is parallel to what's given? So to create a parallel line, all we do is take the line that we already have and move it either up or down. So for example, let's see. So for example, we have this line already, and if we move it up by say 1, 2, 3, 4, we'll get a parallel line. And let's take the same line again and maybe move it down by 4, and we're going to get a parallel line. And we can even move it up more if we want, and we get another parallel line. So we take the same line and just keep moving it up or down. So what stays the same is the slope, but what's changing as we're moving it either up or down is the y-intercept. So what we know about parallel lines, parallel lines, is they have the same slope and different y-intercepts. So let's find the slope of the line that they gave us and then figure out which equation has the same slope. Okay. So we know that slope from a graph is rise over run. Choose 2 good points, which in this case they gave us 2 good points already. So rise is either up or down. If it's up, it's positive. If it's down, it's negative. Run is always to the right, which is always positive. So starting from this point here, my y-intercept, I'm going up by 1, 2, 3, 4, 5, 6. So that's a positive 6, and my run is 1, 2. Now 6 divided by 2 is 3. So the only equation that has the same slope as this is y equals 3x. So that's the same slope. Let's check the y-intercept. My y-intercept of this line is -1, -2, -3, -4, -5, -6. And the slope of the y-intercept of this line is -4. So they both have the same slope, but different y-intercepts. Check. The next one we are going to do is number 27. We need to write an equation for this situation. Keywords: per, each, or every. Whenever you see any of these words, we know that the number that goes with that word is the slope. So if I look in my situation, it says the cost is $39 per day. The number that goes with per is 39, so I know in my equation I'm going to have y equals 39x which is going to be my m, or my slope, and y equals mx plus b. Now let's find the y-intercept. Normally the y-intercept is going to be an additional fee or charge, and in this situation I don't have that. So I'm just going to write plus 0. And there is your equation for this situation. Now let's look at number 29. Number 29. So we're given a line and we need to shift it up by 3 units. And we just talked about that with parallel lines in number, I forgot which number, but we just did it a little bit ago. So again, we're taking this line and we're shifting it up or translating it up by 3 units. So if I'm starting here at 1, 2, 3, if I shift this line up to 3 units, I'm going to be at 4, 5, 6. So my new line is going to be here. The slope has stayed the same. The only thing that changed is the y-intercept. The y-intercept went from a positive 3, and we shifted it up by 3, and now it's at a positive 6. So in my equation, the y-intercept of positive 3 is going to change to a positive 6. And that is number 29. Now, number 31, we already talked about Hoyvux in number 21. So for number 31, refer to number 21. The next one is 33. Okay. And for 33, you're going to refer to number 9. Okay. Except this time, since we know x is domain and y is range, this time they gave you the domain, which is 0, 1, 2, and 3, and you just need to find the y values. So just put the function into your calculator and then find what the matching y values are, or you can just plug in your x values and then see what you get. The next one is number 38. Okay, negative 7 divided by 0. So if we type that into our calculator, negative 7 divided by 0, enter. And it says error, divide by 0. This means that we cannot divide by 0. And what we call that is undefined. Okay? So I'll put a star here. We cannot divide by 0. So 0 is on the bottom of your fraction. The answer is going to be undefined. The next one is number 43. What type of correlation is shown in the scatter plot? Right? So we can either have a correlation that is positive, and we know a positive slope goes uphill. We can have a negative correlation, which means the data is going to be going downhill. Or we can have no correlation, and the data is scattered all over the place with no real pattern. If I look at the data that I have, although it's scattered, so if I look at the data that's given to me, although it is scattered, in general, it is moving uphill. So I know that I have a positive correlation.